everyone. Today we are going to learn about heat and temperature. So this is your 14th unit. So here we are going to discuss about heat as well as temperature and what is the difference between heat and temperature and uses of this heat and temperature in our life. Right. We'll start then. Here you may have experienced this. What is this? That someone's hand is kept under pouring water. So why is that? You can see very well that there is a burnt hand. You also must have got this experience at home. So what do you do? What do you do if you get yourself burnt? Usually what we do is we go and keep our hand under water, or we can keep some ice on it. What else we can do? We try to cool it out. So when we try to cool this, actually we think we are cooling our hand. We are cooling our hand, but it is not. What is happening here only we are going to learn with this lesson. We will see what is happening here. That is, of course, water is cool. Now your hand is burnt and it is hot. Temperature in your hand is removed out with the help of this cooling substance. Now, we learned that it is actually not that your hand helped to cool yourself, that water, as I told you, your heat in your body. You have heat in your body that is transferred to that water or to ice cubes. Because of that you are getting the pain release from your body. So, we will see now what is this hotness, or we call it coldness. You have this experience very well early in the morning that you get a hot cup of tea or hot milk from your mother. So, when you touch it, sometimes you say it's too hot and you don't drink it, and you keep it somewhere and you just wait till it get cool. Why you are waiting? Because you know that it is too hot. You want to get it cooler. You want to get it cooler. So, it is something that you feel. It is very hot or very cool. That is, of course, heat. But there should be a way to measure. There should be a way to measure. That is what we are going to learn from here. So, we will see. Now, here there is one ice container as well as a hot cup of tea. You all must have this experience that you must have touched a cold cubes of ice as well as hot cup of tea. This is what you do if you don't like to drink hot cup of tea in the morning. So, what do? You touch and see whether it is okay to drink. Then here obviously when you touch, you feel something cool. But here when you touch it, you feel it's really hot. Or after some time you see the difference between this heat in that tea. So, you can feel it. Always heat can be felt by you. So, this heat can be felt by you with the help of this temperature. This temperature can be measured as well. So, these are some thermometers. You may have seen few of these. There is a wall thermometer here. There is a mercury thermometer, and this is a digital thermometer. So, we have some thermometers with us. We will see some of these. Here, this thermometer is an alcohol thermometer. You can see there is red color here and it is calibrated this way. So, you can see that the red color is of course used to see it properly. See it properly, that we use red color in alcohol. So, range here is different from the mercury thermometer. At the same time, there is another thermometer. You can see this thermometer is little small in size. Small in size, and if you observe it very well, you can see further details here. This is called a clinical thermometer. This is called a clinical thermometer. So, usually we use these clinical thermometers to measure fever. When you are sick at home, you are using this. So, you have a small idea about these different types of thermometers. Most of you all must have seen these thermometers in previous grades. Right. Now, you know that we have to do an activity. You can do this at home. Simply, you can take a container, similar size of 2 containers. One should be filled with lukewarm water. What is this lukewarm water? You are not going to put your hand into boiling water, hot water, water which you can put your hand there, you are going to use. Similar, same amount of water we put into same same size of containers. Now, you can put your hands there and see how you feel it. What do you think? Definitely you will feel something different. What is this difference? What is this difference? Here, lukewarm water and cold water. Lukewarm water, you will feel warm. Here, definitely you will feel cool or less warm. Because that they are the feeling cold or hot because of the difference between this heat. Difference between these two heat only that you feel it. At the same time, I showed you some thermometers. If you put these thermometers there and if you take the temperature, you can measure the temperature. When you measure the temperature, you will see the difference as well. So, if you have a thermometer, you can do that, or else we can do that in the laboratory with the help of our mercury thermometer. So, definitely the temperature difference can be observed. Then, we will see there, this is what? This is a hot cup of tea and you can see that steam is moving out. Steam is moving out. This is what happens when you are having a cup of tea, hot cup of tea in the morning. So, when you keep it for a while, you will see that steam is moving out. With that, what is losing? Heat is losing. What is losing? Heat is losing. So, from a substance or from an object, if heat is losing out, if heat loses out, ultimately you know very well, it's day to day life, you can find out that it is cool, it gets cool. So, why? Heat has moved out. Heat has moved out. When heat has moved out from an object, definitely it is getting cooler. The best example is this. You can do this at home, you can experience this at home, and most probably you all must have experienced this very well. If you don't like to drink a hot cup of tea, definitely you must have kept your cup of tea to getting cool. So, there it is getting cooler and cooler more time you keep it. Right. So, then activity 2 is based on finding this different temperature, how it changes its volume. Now, we will see how it is, how the setup is made, right. Warm water you need, cold water you need, then you need 2 bottles. If you can take 2 glass bottles as well as 2 tubes this way and ink. So, I will tell you how to set this experiment out. Very easily you can do this at home. You can find a glass bottle like this. glass bottle like this and put some ink into it, and you can fill water, make it the colored water you can use for this. At the same time, a small stopper like this is necessary, as well as a small plastic tube. What do? This, take a small hole here and put this into this and allow this to come out, right? Allow this to come out this way. After that, you can easily fix this into this. Easily. This is the simple setup. This is the way that you have to make the setup. After that, these type of 2 bottles only that we made here and kept here in 2 different water containers. Then after that, we can keep it for some times. Then after that, we allow it to rise or increase or decrease the level of ink. Here, look at this level only you have to observe in this experiment. We will see what will happen here. Look at this now. You can see very well here, warm water, cold water, see the initial levels. Initial levels are same. You can see the tube of pen is there, colored water, and levels initially it is same. This is after some time. After some time you can see this. Look at this first bottle which was kept in warm water. What has happened to the colored level? It has increased. At the same time, you can see the cold water. The tube which is in the cold water bottle, which is kept in the cold water, you can see it has decreased. Now, you can see the observation very clearly what has happened to this. So, this happens, level of ink in the warm water. Here red color you can see it is warm water, it has increased, clearly you can see. Then after that, level of ink decreased here in the second one. It is in cold water. So, what does this mean? Always we can find out level of ink increases because of the heat. That means heat has the ability to increase this up, and heat has, when heat is not there, that it does not increase up. These two are the main observations we can take here. We see again the conclusion, volume of water increases by gaining heat and volume of water decreases by losing heat. So, we learnt first concept, what is it? Volume of liquid, volume of water always increases with heat and volume of water decreases when losing heat or cooling it. I am sure that you are very sure about the explanation here. With the activity you yourself can do that, practice it at home. Right. Now, look at this setup. Most of these parts I hope that you know. This is a stand, this is a round bottom flask, and it is closed with a stopper as well as a thermometer in it. Same type of the round bottom flask. You know what is this? This is a spirit lamp. So, what we do is, in this setup, we don't cool this, we heat this, and this one you can keep this spirit lamp under the volumetric flask. You can see the volumetric flask here, they are with the thermometer and the stand. Here the same setup, but the spirit lamp is there. So, you know obviously with the spirit lamp this water is getting boiled up or heat up. Here it is not getting heated up. What will happen here? You can see the level of liquid, it has risen up. So, that is called expansion of liquid. Risen up water level in the tube is called expansion of liquid. You don't observe that here. You don't observe that in this setup. So, that means when it is not getting heated up, you can see that expansion doesn't take place. So, you learn another thing. Always the volume of liquid without changing the mass. Mass did not change. What is mass? The amount of matter in it. It did not change. Without change in the mass, when it moves up, that is called expansion of liquid. So, expansion of liquid always takes place with the help of the heat, So, heat is responsible for expansion of liquid. Heat always rises up its volume. When it is not heated, it is not rising up the volume. Right. So, with the help of this, we can use a thermometer. That this expansion of liquid, we learned there are two different types of liquids we know. Some liquids, water, mercury, alcohol, those are the different liquids that we know. Any liquid, if it has this expansion ability, that it helps to make the thermometer. So, I will show you. I showed you earlier also, now again I will show you a thermometer that it is there with some liquid. You can see this thermometer, they are red color. So, liquid used here is alcohol. So, that alcohol is a liquid, it has the ability to increase its expansion with temperature. You know, you can put this into a container or any substance, then what happens? You will see this liquid expands. At the same time, now I will show you a mercury thermometer, actually a clinical thermometer. We will see that when you are sick at home, that you can use this clinical thermometer with your body temperature. With your body temperature, it increases up. So, these days of course, we are using digital thermometer everywhere, you may have seen that. So, with this expansion is found not in those digital thermometers, here in these liquid thermometers. If it is with any type of liquid, you can find out that this expansion ability is used to measure temperature. So, we will discuss about this expansion power. It is a property. This expansion of liquid is a property. We use this property to measure, to make this thermometer to measure temperature. Right. You may have seen this in your school laboratory, or you can make this at home without any large equipments, big equipments, you can use this. I will tell you what are the main things yet that you need. You need a thermometer, paper strip, just a piece of paper, strip, tube of pen. You can use your carbon pen tube, and it is very much better if it is an empty one. Then you, as I showed you earlier, the same setup. I will show you again what I showed you earlier. This, the same setup as this you have to make to fix here. So, to this tube, it should be little longer than this, paper should be fixed. When the paper should be fixed to this, first you have to label this with same numbers, same calibration you call it. The space between each scale is same, each line is same, and it is kept this way. This is glued to this pen tube and your thermometer is there. Now, what do? Here it is kept in a water trough. Now, water trough, you can heat it up. Once it is heated, it will stop somewhere there. So, then this tube also has taken that temperature. You can mark that temperature here in this scale of paper. Secondly, again repeat the experiment and you can mark another level, another number there. So, few numbers you can label there. After that, those numbers equally should be divided. So, example, you can see the long lines here, 1, 2, 3, 4, 5, 6. 6 long lines are there. Each line you equally divided according to the temperature you get in this thermometer. So, with the help of that, you can make a usual bottle thermometer at home. So, in this bottle thermometer, then we can use, now it is marked. It is marked with the number. With the help of that, if that goes to this number, what is the temperature? If that goes to this line, what is the temperature? That by using this bottle thermometer, without using this, you can use to measure temperature. So, here further it is explained more here that this is the setup you first make. After that, this is how that it is kept in water. After that, you can see the thermometer in the last diagram, and with the stand, with the help of the stand, now it is you boil that water. When it is boiling slowly, you can use a spirit lamp or a Bunsen burner. When it is boiled up, you can see that this temperature on the thermometer tallied with any number you mark on the paper that is written there. So, few times you do it again and again, and for few different temperature, after that you calibrate it. That means scale with the same space, you can mark it on the paper, then can form a bottle thermometer. So, easily you can make a bottle thermometer to measure temperature. Then the method is there given here. Beaker should be heated up, then mercury thermometer should be dipped there to see the real change. Accordingly, we can find the temperature difference on that, the scale on the paper. So, relevant temperature should be indicated there, and after marking several temperatures that you can use it as a thermometer. Right. Have you all seen this? This is a thermometer usually we use in the laboratory. Actually, this is called a laboratory thermometer. This is basically with a mercury end. It is made out of mercury. These days, other than for laboratory thermometers, we don't use alcohol thermometers because mercury is very, very poisonous. If you happen to touch that, you mustn't touch it. It is harmful, corrosive, so you mustn't touch mercury. So, you can inform your teacher if you break one. Then we will talk about this, that thermometer mercury end is dipped. It is called the bulb. That is dipped wherever you want to find temperature. There is a scale here. On its own, that there is a scale. With the help of changing scale, that you can check thermometer, you can check temperature by using this mercury thermometer. Right. So, water bottle thermometer can be used, of course, to measure unknown temperature. That is not, you can't make it with a very, very long range, but it is for a short range you can use it. There are thermometers which you can use for long range as well. Right. Now, look at this diagram. You can see different numbers here. You can see a word Celsius, you can see a word Kelvin, and 0 degrees Celsius, 273.15 Kelvin. So, all these are related to what? Temperature. So, temperature is the measurement which we use to measure heat. Temperature is a measurement which we are using to measure heat. Look at this. These both are the same thermometers, but here it is 0 degrees Celsius, but here 273.15. What is the difference here? You can see degrees Celsius and Kelvin. Degrees Celsius and Kelvin. So, two different measurements are there, but same level. Same level. In other words, 0 degrees Celsius is equal to 273.15 Kelvin. So, that is the equal level. So, this is of course divided into 100 parts in this Celsius. You think that you are climbing up 100 steps with the same height. So, likewise, there are 100 lines there with the same space. You call this calibration, and when you take this Kelvin scale as well, from 273.15 to right above that there are 100 scales. So, obviously, you can find out this is the lower point, lowest point here. Two different points you can find with different scales. So, there is something called SI unit. You may have heard about SI unit when you were in lower grades. Standard unit. Standard unit we use as whole, that every one of us we can use this. So, it is Kelvin, not degrees Celsius, not Fahrenheit, it is Kelvin. Children, all these are scientists. All these are scientists. To honor them only, that Kelvin, Celsius, Fahrenheit names are given to honor those scientists. So, this Kelvin is the standard unit. So, everything has a standard unit. Temperature, the standard unit is Kelvin, which is 273.15 Kelvin when it is 0 degrees Celsius. So, if you are asked what is the standard unit for temperature, definitely Kelvin. Kelvin should be written with capital K, capital K, right. So, now look at this. Can you see the lower point here in the first one? 0 is marked. Then can you see that the uppermost point, that is 100 is marked. Then when you look at the second one, there you can see there are 100 lines in between. So, each line, look at this, then you can see each line is 1 degree Celsius. Each line shows 1 degree Celsius. So, easily you can take the thermometer and you can measure with the help of this scale where the liquid has stopped. So, when the liquid is stopped somewhere, that is the place where you are going to take the temperature. There are 3 scales: Celsius scale, Fahrenheit scale and Kelvin scale. So, you can see Celsius is written as degrees capital C. So, you call it degrees Celsius. Fahrenheit scale, it is written as degrees Fahrenheit. So, you can see degree sign and capital F, and Kelvin scale is capital K. There is no degree sign there. So, if you are asked to write SI unit, always you should write only capital K. Right. So, we can see different types of thermometers. Different types of thermometers are there. I showed you a few types. Alcohol thermometer, you know very well now how to find it out. It is with red colored liquid. Then mercury thermometer. mercury color is silver color. So, mercury thermometer you can find with this mercury color, digital thermometer. The corner one is the digital thermometer. Anyway, all these thermometers that we can use to measure temperature. Right. We see there are some boiling points and freezing points given there, different with different scale. I will tell you what is boiling point and freezing point later on. And here you can see, I want you all to see the differences. Can you see boiling point of water? If you take Celsius scale, it is 100, Fahrenheit 212, Kelvin 373. And at the same time, there is another thing that you must learn here when you are drawing a table this way. If you write your unit at the top peak of your table, you never write the same thing again. That is the very reason that it is not written there. You can see when the unit is written, you don't repeat the unit, they are in the table. So, other things, freezing point also you can see the difference, and mean temperature of human body. You know our temperature 36.9. If it is Fahrenheit 98.4. If it is Kelvin 309.9. So, you can see the differences here. When you take different scales, you can see different numbers. So, make sure if you are talking about temperature, you have to talk about this unit definitely. If not, you don't know what unit that you are referring to. Right. Now, we see, I told you that we are going to talk about boiling point. We see what is boiling point. Constant temperature, not changing temperature, at which a liquid substance, there are so many liquid substances, we can say water, petrol, diesel, oil, coconut oil, if you melt chocolate, yes, that is again liquid substance, changes it to its gaseous state. You are going to turn into a gas. How? By giving heat. By giving heat, you can turn a liquid into gas. So, if you can see this lower level line, you can see here it is blue color, blue shades off, and it turns into red. Red means more hotter. Red means more hotter. So, what do you think? Liquid is cool. The gas of the same liquid is hotter than that. What does that mean? That it has gained some heat. It has gained some heat. So, you need a temperature to change this state. You need a temperature to change from liquid to gas. That is called the boiling point. It's an exact temperature. It's a constant temperature where liquid substance turns into gaseous state is called boiling point. Right. So, as I told you, water or any liquid, don't misunderstand always that it is water. Water or any liquid absorbing heat to turn into steam. Steam word is only for water, but it can be any gas. So, that is boiling point. Boiling point of water, all we know, that is 100 degrees Celsius. So, 100 degrees Celsius, some iron and some other substances are there, their temperature increases to very, very high level as thousands. So, any constant temperature that by absorbing heat, turning state of matter. This is liquid, that is gas. If it is turning, that is called the boiling point. Then, we will see what is melting point. You know, day to day life, you know very well that solid ice. Ice you have seen. You keep it to put it to your drink, cool drink, or you put it to take it to make a juice. You keep it on the table and go somewhere. By the time you return, you can't see any ice cubes. Why? What has happened? ice cube was as a cube or solid as long as it is kept in the fridge when it is in a cooler condition. Can you see this blue color in that lower strip? Yes. Now, when you keep that out in the room temperature is much more higher than that. So, it is absorbing heat and turning into a liquid. Solid turns into liquid. So, then what is melting point? That is also constant temperature. So, also constant temperature at which a solid substance changes to its liquid state. The solid substance changes into liquid state. So, that is called the melting point. Right. Melting point, what happens again? Ice is there, solid, absorbing heat. Heat should be absorbed, it turns into liquid. If it is ice, ice turns into water. Right. Freezing point. Now, we learnt about boiling point, then we learnt about melting point. This is freezing point. If you want to freeze something, if you want to cool something, what do? You have to keep it in the fridge. If you want to drink cool water, you just put it into a glass or vessel and keep it in the fridge. When it is kept in the fridge, if it is not the deep freezer, this doesn't happen because it solidifies below 4 degrees Celsius. So, if you want to make solid ice cubes, you have to keep it below 4 degrees Celsius. So, that is the freezing point. The constant temperature at which a liquid substance changes to its solid state. This is a liquid, this is a solid. So, changing liquid to solid, what is happening? Cooling. So, that is called freezing or freezing point. There, the constant temperature at which liquid water changes it to ice. You see something 1 atm here. That is the standard atmospheric pressure. When pressure changes, this changes, children. So, freezing point of water is always 0 degrees Celsius. If you want to take liquid into ice, you need 0 degrees Celsius. If you want to turn ice into water, again 0 degrees Celsius. Again listen, their freezing point, that is 0 degrees Celsius, that is water freezing point. Water freezes into ice, 0. Then ice is there, ice again you want to melt. If something is there to melt, that is melting point. Melting point of ice, what is melting? Ice is melting. So, that is also 0. Remember, that is only for water, but boiling point of water is 100 degrees Celsius. So, you know the definitions now. What is the boiling point? What is a melting point and what is freezing point? Here, this experiment shows how we are going to find the melting point of ice. Very easy. This is the setup. What do? You fix a thermometer, then melting point of ice. You can find out when these ice are getting melted, the temperature you read from the thermometer. So, when all are getting, when the ice cubes here till it gets melted, you can find the temperature. You will see temperature will remain at 0 degrees Celsius. This is a diagram you can see that how to find melting point of ice. There are some substances here given. So, here melting point is given with degrees Celsius, and again as I told you, it is there with atm. Ice 0 degrees Celsius. Paraffin wax, you know what is paraffin wax, what we use in candles, 60 degrees Celsius. Lead is a substance, metal 317. Iron 1539 degrees Celsius, very much high. So, you can understand that to melt even that much of temperature is required means with the help of the 100 degrees Celsius boiling point of water, you can compare how much high that is. Look at this. This is how that you can find out boiling point of water, right? This is a setup. There is a small change that you have to do in this setup as well. If you are really finding boiling water temperature, I will show you a small setup there, how this is set in the experiment. Here that we have the setup, there we'll look at this setup. You can see, children, this is a stand, this is a mercury thermometer which is fixed. You can see it is not dipped in this water. You can see water here, but it is not dipped in it. Then it is held by this stand. After that, you can take a spirit lamp and boil water, allow to boil water here. After boiling water for some times, you can see what will happen to it. So, you can keep this way. Make sure that this, do not allow this bulb to touch with this water level. Why? We are measuring steam, temperature of steam, not boiling water. We want to find the boiling point of water. This is water boiling point. So, you can see, if you can see here, there is mercury level. When it is getting boiled or heating up, mercury level in the thermometer is moving up. You can observe here. So, after some time, now it is actually at 50 degrees Celsius. So, we will see how much it will go. We will keep it for a while and we will see how it will go up with heat, when heat is absorbed to water. So, that is the upper fixed point. Ultimate point which it can go is 100, not beyond that, because that water vapor turn liquid into water, or water turns into water vapor at that point. So, that is a Celsius scale in that. Here there are some substances. Again, same as earlier, children, you can see alcohol boiling point is 77 degrees Celsius, paraffin wax 370, water 100 as I told you. Look at lead 1744, iron 2900, very much high. Iron is very much high in boiling point. So, right, then you can see there the thermometer reading. How do you read a thermometer? You need to fix the thermometer first of all. So, thermometer should be fixed this way, and you never take the thermometer somewhere down and you don't take the level down. So, all of you all can see this thermometer. If you are taking to your eye level and reading the thermometer, it should be right at your eye level, not somewhere else. Or else, if it is fixed to a stand, you have to bend yourself, lower yourself to the level of your eye level there at the thermometer. That is what you can see here. There, here at this point, you can see 20 degrees Celsius is always measured here when the eye is kept here. So, their eye level always kept it where you should measure the thermometer. Same as the way that you measure your water in measuring cylinder. You know how you measure it. You keep it on a stable surface and take your eye level to your meniscus level. So, same as that, you have to take your eye level to the level where the liquid has stopped. It can be mercury, it can be alcohol, where it has stopped, you have to take it to your level. So, these are the different ways, children, that you can find out that how to measure temperature in different ways. You can fix to a stand or you can hold it right on top, not at the middle, right on top only, that you have to hold the thermometer. So, if you hold it somewhere else, you don't get the temperature correctly, accurately. Why? You are affecting your body temperature, affecting the temperature of thermometer. Right. So, there are different ways that the measuring is given. Okay. Look at this. This is a clinical thermometer, one of the most important thermometers that we use in our day-to-day life, especially this period. We need this. This is used at home. You can, like, it's better if you can have a clinical thermometer at home. It's really, really important to check your temperature difference. I'll show you the size, real size of the clinical thermometer now. Look at this. This is the real size of the clinical thermometer. I will show you that with the alcohol thermometer and see, you can see the difference. See the two sizes. So, small one is the clinical thermometer, this is the alcohol thermometer, and mercury thermometer is also the size of this. Why we have this clinical thermometer very small? Because it is with a very short range. Look at this, children, and here the range is from 35 to 42 or 43. Obviously, you won't be able to measure 41, 42. That means very, very high fever. So, there at the same time you can see a fine bend here. Thermometer has a fine bend here. So, this is the clinical thermometer, that which we use to measure your temperature. Right. Here the temperature range you should know, 35 degrees Celsius to 43 degrees Celsius, and clinical thermometer is used to measure body temperature. There is a way, there is a method. However you like, you can't use clinical thermometer, especially these days. These days it's very much better if you don't put it into your mouth. Usually you can keep under your armpit, especially for babies that they do that. So, if not, the best thing to take your temperature is under your tongue. Keep the mercury bulb under your tongue. So, first bulb of thermometer should be cleaned with the antiseptic material. Something to clean, alcohol, you know very well that alcohol should be taken and it should be cleaned. After that, keep it under armpit or under the tongue and take the temperature, let it be few minutes and take it out and hold it vertically. I will show you again how you are holding that vertically, this way. You don't take it somewhere else, you can take it, hold it vertically like this and measure your body temperature. If not, you will get different temperature, not the correct temperature. So, you will be mistakenly, you will think that you are sick or you have fever or your body temperature gives different amount without reading, if you don't read it correctly, right. So, always, as I told you, body temperature transfer to the mercury of the thermometer, therefore, you can measure temperature there. Always your body temperature passes to the mercury bulb. Then mercury expands with the liquid expansion according to the heat which the body gives, then it increases up. So, that is all that you can talk about this heat. In this case, children, that you have another part here with heat, that is temperature and heat. So, we are going to see when we talk about heat in our next lesson, whether heat and temperature are same or heat and temperature are different, and if there is a difference, what are the differences between heat and temperature, and what are the methods that heat will pass from one place to another place. So, today we learnt about the temperature and how temperature is measured, different scales of temperature, how temperature changes according to losing heat or giving heat, and we talk about few small activities, even if which you can do at home even, that few activities to show liquid expansion and how liquid expansion helps with the help of heat. This is all for today, children. Then you will learn about heat from next lesson. This is for today. Hope you learned something about temperature. Goodbye and see you next time.